for those that don't know, on Monday, April 8th, there's going to be a total eclipse, which is this cosmic event where the moon is in front of the sun, it casts a shadow on Earth, and because the moon is 1/400th the size of the sun, and the sun is 400 times further away from Earth than the moon, it's like a perfect match. And it's this like cosmic circumstance that is mind-blowing. And a friend and I were like, well, unfortunately, most people can't experience that eclipse and can't experience that wonder and amazement. So why don't we actually do the exact same thing, create the same degree of wonder and amazement inside of Figma with a plugin? So we're going to create an eclipse plugin to do the exact same thing that's unfolding in space in Figma. And I guarantee you, if you can't see the eclipse, you will feel the same like sense of wonder and awe from this plugin. So the idea here is you're going to select something in Figma, like this image, and a shadow will move across it when you run the plugin, and you'll be like an eclipse. So let's like build this thing. Let's speed run an eclipse plugin. I've built this once before live on a video for my team, and it took like 20 minutes. I think I can do it more quickly now that I've done it one time, but let's just go. There's going to be bugs and it's fine. So the first thing we're going to do is we're going to do figma.notify. This is a way of sending a message in Figma, and we'll say an eclipse is unfolding. And then we are going to do figma.close plugin. And that's going to close the plugin for us. So when we select something, we run this, an eclipse is unfolding. Perfect. So now what we're going to do is we're actually going to put this in an async function, which allows us to do async things. And I'm just going to call it run. And we'll move these up and in, and we'll do run. So that's going to effectively do the same thing, except now it gives us an async function to kind of do some stuff inside of. So the first thing we want to do is we want to get the current selection, because the shadow that we're going to move across the image has to be relative to the size of the current selection. So we'll call it the node. Is figma.currentPage .selection 0. So selection is going to be potentially more than one node, like if you select more than one thing. So we just want to get the first one, which is in position 0. But also you might not have anything selected. So in this case, we want to make sure that it exists. So we'll say if node, then we will await a new function called perform eclipse for the node. So I'm going to put the node as a param or an arg for that. Otherwise, it'll just keep going and close the plugin. Maybe we'll say else, how about this? We'll move this in here, and then else we'll say no selection, no eclipse. Perfect. So this means that nothing's selected. This means something is selected, which is great. Wonderful. So now we need to actually describe this function called perform eclipse. We'll say async function perform eclipse, and for now we'll just return true. Sweet. So now, you know what? How about this? We'll console.log node, make sure that this is working. Select something, run eclipse, boom, rectangle node. When you paste an image in Figma, it's a rectangle with an image fill. Great. So this works. And then if we run this now, no selection, no eclipse. Perfect. So the first thing we want to do is actually get the dimensions of this image and make the eclipse size relative to that node. So we'll say the eclipse shadow is going to be a circle ultimately. And so we want that circle to have a diameter that is as big as this image that's currently selected plus a little bit more. So the way that we'll do that is create a new variable called diameter, and we'll do math.max, which means whatever is bigger, node.width, node.height. So in this case, since it's a landscape image, the width is bigger than the height, so this value will be the width. If this was portrait, it would be the height. And then to make it bigger, we'll just multiply by 2 arbitrarily, because if we round those corners, it won't cover the entire image. So let's do that now. So let's create a shadow really quick. And that's going to be a rectangle in Figma. Create rectangle. And so we can see the size. We're going to say shadow.resize diameter, comma, diameter. Sweet. So now we should get a shadow that's big enough. Oh, we weren't selecting anything. Boom. So here we go. It's twice the width because check this out. When we do shadow dot corner radius equals diameter divided by 2, delete this. We have a circle that's now going to be the right size, right? Sweet. If this was the same dimensions, this would not cover the whole thing, right? So that's why we're multiplying that by 2. Let's make it semi-transparent black because that's what a shadow is. So shadow.fills, and fills are an array of fills. You can pass in as many as you want. We're going to pass in just one, and that's going to be type solid. And then the color is going to be an object. R is 0, G is 0, B is 0. So that's black. If it was 1, 1, 1, that would be white. And then we'll say the opacity of this fill layer is 0.8. 1 would be 100%, 0.8 is 80. So now when we select this, boom, 80% opacity, perfect. I think we can even do shadow.blend mode equals multiply. I believe that would work. Let's see. Yeah, multiply. Perfect. Great. Not that that really matters, and not that that's what a shadow does. Does a shadow multiply? I don't know. Okay, great. Next, let's blur it. So we'll do effects, which is also an array of objects, and this will be called layer blur, and then we'll do radius. Of that will be diameter times 0.1, or 10% of the diameter will be the blur. And then I know this is a little gotcha. Visible equals true. You have to explicitly set that it's visible. All right. Something's messed up. Object is not, oh, effects, plural. Let's do that. Whoops. I saw it work for a second there. There we go. There's our blur. Wonderful. This is annoying. We're going to come up here. We're going to do console.clear. So every time this runs, it'll clear the console for us, which is nice. Wonderful. Okay, let's position this thing. So down here, we're going to write the start X, which will be, if we want to position this bottom left to top right, right? Because at least that's how this eclipse is working in North America. Bottom left, top right is the direction that this is going to go. So the start X needs to be the bottom left. So what we want that to be is the current selection, the node's X, which will be the left X on the node, because the X and Y are the top left-hand corner in Figma. So the node X minus the shadow.width, and then const start Y equals node.Y minus plus node.height. And then let's just set shadow.x to be the start X. Let's spell things correctly. Shadow.y, start Y. Put this where I want it. Perfect, right? So this is right in the bottom left-hand corner. We're also going to get the end X, and that's going to be upper left, so that'll be the node X plus the node width. And const and Y will be the node.y minus the shadow.height. And just so we can see what that looks like, I'll change these to end. So now when we run this, this will be in the end position, right? Up there. Great. So we have a start position, end position. Now what we need to do is animate that, right? Over time to go from start to end. And so what we're going to do is we're going to create a new function called step. And I know that this actually needs to return a new promise. Oh my goodness. We're going to get a resolve. This is kind of like an async await situation, except it's explicitly returning a promise that allows us to do some different stuff than if it was an async function. So we're going to await step. So we're going to wait for this thing to resolve. And so what we want to do is, how many times do we want to, like with an animation, you have to figure out how many frames, essentially. how many frames are you going to animate from start to finish? We'll call those steps, and we'll say it's 100 for now. And then we want to set the current frame, or the current step, or the I index, is a typical thing in development that we do for this, to be 0. So I is going to become 1, 2, 3, all the way up to 100 over time. So inside of our step, we're going to say progress equals I divided by steps. So the first time through, that's 0 divided by 100. The last time through, it'll be 100 divided by 100. And then anywhere in between, it'll be whatever that, on a scale of 0 to 1. So that's progress. And then we want to make sure that we're increasing I so that the next time through, await step, or no, sorry, this isn't async await. We'll resolve step. Perfect. So this will run 100 times, and actually, we want to say if I is less than or equal to steps, then run step again, else resolve and be done. Perfect. So let's actually see this run. Console.log progress. So now this should run 100 times. Oh, something's wrong. I before initialization. Oh, this needs to come down here. We were calling this before we defined this stuff. Great. So we can see in the console 0 all the way up to 1. So that's running 101 times from 0 to 100. Wonderful. So now what we want to do is we want to actually, first of all, that was the end. We want to set it to be the start. We're going to copy this down here, and we're going to say inside of this, the shadow x is the start x plus diff x times progress. And diff x doesn't exist yet, but let's actually just write this out, and then we will write what diff x and diff y are. So const diff x is going to be the end x minus the start x. And then const diff y is going to be the end y minus the start y. Wonderful. So that's the distance that we're essentially going. So we want to do start x plus whatever that is times progress. So the first time through it'll be times 0. The last time through it'll be times 1, which means that any time in the middle it'll be a fraction of it. So when we run this, actually, it's going to not work because it's going to run 100 times, but instantly. So what we want to do is we want to actually delay each frame, right? So this is running, as we saw earlier when we were console logging, it's running 100 times, but it's not actually drawing that 100 times on the Figma canvas. So we want to delay this. And the way we do that is with a set timeout. And we can call resolve step, and we'll say do this. And actually, we don't need this. We don't need this. We don't need this. This will look nicer. We'll do this every 50 milliseconds, right? So every frame is going to have a 50 millisecond delay from the previous frame. So now, there we go. So what is this frame rate? So 50 milliseconds per frame times 100 frames is 5,000 milliseconds, which is 5 seconds. So that's a 5-second animation. If we brought that down to 20 times, well, actually, we could make it take as long as the actual eclipse, which would be 4 minutes, which would be 4 times 60, so 240 seconds. So 240 seconds. Whoops, 240 seconds times 1,000 milliseconds. That's 240,000 milliseconds divided by 100 steps is 1 frame every 2.4 seconds. So if we make this, this would be a 4-minute unfolding. Every frame. That's so funny. We want to actually increase the amount of steps then, right? increase the amount of steps, reduce the amount of time between steps. But this would technically now unfold in 4 minutes, which is, I think, what my son is actually coming right into. Not my child. My son is your son. We all share the same son. It's setting right now. Okay, I'm going to cancel this because that's going to take forever. And what we're going to do now is we're going to bring this back to 20 milliseconds because, you know, we'll just speed it up like that so that it's actually possible to understand. And then at the end, instead of me manually deleting this every time, we can just do shadow dot remove. Sweet. So now if we run this, whoop, gone. Wonderful. And then the plugin closes and we're good, which means now I should be able to like make this full screen. Let's zoom this all the way in. And we're sitting here and we're going to watch the eclipse together. Hope you had fun. I had fun. 16 minutes. See you later.